Okay, 3, 2, 1.
Hello and welcome everyone. Thank you for joining us today for this live Q&A. So today what we're all here to learn about is we're here to learn about what life is like on the moon. So many of you on the call are participating in the Future City Experience, where you have to design and build a city on the moon using 2 lunar resources. And so we thought that's a pretty big challenge. And so in order to help you out with that, we've put together this panel of experts that are actually doing some really neat, unique work on getting us to space and working in space. Before we get started, I just wanted to let you know that this is the Future City Experience is a collaborative effort between a number of different organizations. So it's brought to you by Engineers Canada. It's the organization I work for. I'm the outreach manager there. And we represent the 12 provincial and territorial regulators that help to regulate the profession. We work with them. And this is also a collaboration with Engineers of Tomorrow, which is a nonprofit organization that exists to inspire the next generation of engineers, and with Ontario Tech University. This is a university that helps to train the next generation of engineers. And they're actually working with us to do the big showcase that you're going to all be part of on May 5th. The other thing I wanted to let you know about is that some of you would have seen that there's an opportunity for you to ask questions live to the panelists. And many of you already put some in, so that's fantastic. But there's still going to be a chance for you guys to add questions throughout the presentation. So the way that you would do that is you use Slido. So that's the link that you would have seen as you're coming in, but just in case you didn't see it, it's literally just Slido, slido.com. And then what you want to use is the specific key, which is 69971. And so that's how you'll be able to ask questions direct to the panelists. So without further ado, what I'd like to do is introduce to you today's moderator. So the person who's going to walk us through this very interesting conversation. It's with great pleasure that I introduce to you Dr. Mark Rosen. So Dr. Rosen is a professor at Ontario Tech University, which is located in Oshawa, Ontario, where he has served as the founding dean of the Faculty of Engineering and Applied Sciences. So that basically means he helped to get the engineering department started at Ontario Tech, which is a big deal. He's had a very long, exciting and successful career. He is a mechanical engineer by trade with expertise in thermodynamics, energy technology, sustainable energy, and the environmental impacts of energy systems. So he'll be able to give you some very interesting information that you'll have to think about on the moon. So without further ado, I'll pass it over to Dr. Rosen.
And thank you very much, Kim. I appreciate the kind words and also the general introduction to what we're going to be doing today. I'm really excited. This is awesome. Hearing what you folks are doing through the Future Cities competition blew me away. I've had students work on aspects of designing better cities, but I've been relatively dull and limited to Earth. You having to deal with the moon, wow, that's really a challenge. And I'm really excited because we have an awesome group of panelists here today. Blows me away when I heard about the experiences that they've had and the things that they've accomplished. So I think they'll bring a lot to play in our discussion today. I'll moderate this activity, as Kim said, but I really want to give time to you and to the panelists to share thoughts. But overall today we're all engineers, we're scientists, we're bringing knowledge together in the technical fields to rise to a challenge, a big challenge, a city on the moon, and using resources on the moon. That's wonderful. But engineering, what is it about? We're problem solvers. Give a challenge, whether it's fix something that's broken or build something new, and engineers just rise to that occasion all the time. This activity seems to be no different than that. So I think you're in for a wonderful treat. We do have the 3 panelists that you see on your screen, or will see shortly if you're not seeing them all right now. And I'd like to first introduce them all and then give them a chance to share some initial thoughts before we get on to questions. So let me do that first. I'll start with Marla Herring. She's joining us today. She's a systems engineer at MDA, which is an international space mission partner in Ontario, in Brampton, near Toronto. She's currently part of the Canadian team that's building, testing, designing hardware components for what's called Spider. It's a space robot, really, and it's a payload on one of NASA's missions. This spacecraft is going to help repair satellites, extend their lifetimes, things that are important, cleaning up space garbage even. She's an aerospace engineer. She's also an officer in the Royal Canadian Air Force, which has allowed her to do wonderful things like travel across Canada in an F-18 jet fighter. Spent a lot of time there, and she's an aerospace engineer. So she brings a lot of experience. I'll move next to our second panelist, which is Dr. Ryan Kobrick. Ryan is at Paragon Space Development Corporation in the United States, a company that's worked on basically every human flight mission that NASA and others have had since the 1990s, and their hardware is flown on NASA spacecraft. He's a mechanical engineer, studied at Queen's University in Canada, but then went on to graduate work in the international realm in aerospace and space sciences. He's even studied bioastronautics, which is just a fascinating area for me to think about. In addition, he's participated as a crew member, in fact, the lead in a simulated Mars mission where you use Earth to simulate Mars, but this is up in Devon Island, far north of Canada, well above Hudson Bay. And he was there with the team for 100 days, from what I understand. So another fount of experience and wealth of knowledge for you. The last panelist I'll move on to is Dr. Cassandra Marion. Cass is a science advisor for the Canada Aviation and Space Museum. She's a PhD in geology and planetary science and exploration. She studied at Western University in these areas. Her research focuses on meteorite impact craters on the moon, on Mars, and analogs to that in the Canadian Arctic again. She has considerable experience with robotic and human missions that are designed to prepare for future missions, basically learn so that we can be ready for the future. She has a passion for this area and, in fact, improving science literacy across Canada. So with these three panelists, I think there's a lot that we'll be able to gain by way of knowledge. What I'd like to do now is give each panelist a chance to give a few opening remarks. So let me go back to the start, and Marla, turn to you.
Sounds good. Thank you, Mark. So as Mark mentioned, my name is Marla. I work for MDA. For anybody who doesn't know what MDA is, if you pull out a $5 bill, you can see some of our most famous space robotics, which is Canadarm2, which is on the space station, and Dexter. And we're currently working on Canadarm3 for Lunar Gateway. I grew up in Sudbury, Ontario, and Sudbury is a nickel mining community known for being a meteorite crater. So any kid who grows up in Sudbury learns a little bit about space, and that's kind of how I caught the bug. When I was in high school trying to figure out what I wanted to do, I was really into music, but also took all the math and science courses I did. And so I knew I was into space. I looked at how did people get to space, and a lot of them had a military background. So after studying aerospace engineering at Carleton, I joined the Air Force, and that gave me some really cool opportunities to live in all sorts of different provinces in Canada. I've lived in BC, Cold Lake, Alberta, in Winnipeg. And then I got to do some cool stuff with cool technology. I spent 5 years working with the F-18, and my favorite part of that job was I was doing testing on new equipment that went on it, and I got to fly a lot, which was awesome. Once my contract with the Air Force ended, I really wanted to get back to my passion, which is space. So I just got in touch with a friend from university, and now here I am. I work at MDA. I spent the past year working with an amazing team on designing and testing components that are actually going to go to space for space flight. And I can talk a little bit more about that later. yeah, so that's just a little bit about me, and I'm really excited to be working with you guys and sharing a little bit about engineering and how we get things to space and to the moon. Thanks.
Oops, Mark, you're muted, but I guess I'm up next.
Thank you very much. Yes, thank you, Marla. Great to hear of how you got to where you are today. I'd like to give Ryan next, yes, the same chance to do that. Please, Ryan, floor is yours.
Thank you. Hi there, I'm Ryan. I'm currently living in Colorado. I'm originally from Toronto. That's my hometown. And I've been chasing human spaceflight for my entire career, both in school, after school, like through university, and then on after that. I've always been fascinated with exploration, not just space exploration, just exploring anything, our Earth, underwater, all those things. And the kind of the future of what that might look like for humanity. And it's extremely important that we look kind of forward and outward, if you will, into the cosmos and look at how humanity as a species can not just survive, but also thrive and grow. And as an engineer, the one thing that kind of drove me was that I was always interested about the way things worked. And I really wanted to figure out, how does that work? What is that, what are those parts? How does that fit together? And so, as a kid, I would take things apart, sometimes put them back together. But mostly those are the kind of curiosity type things that drove me. And so currently, I'll jump all the way to the end of where I am now, and I can kind of fill in the middle. And I'm excited to share with everyone today across Canada about your questions about the moon. But I'm currently working on the human landing system for Paragon. And we're working on the ECLSS, which is the Environmental and Control Life Support System. That's what keeps the humans alive inside of the spacecraft. That provides them the air, gives them oxygen, removes the carbon dioxide. And we'll talk about a little bit more of that later on. So it's really exciting to be designing the next vehicle that's going to take humans to the moon. As part of that, I'm also working with this group that's called Dust Mitigation Working Group. We're essentially looking at the interaction with the moon, and we'll also talk about dust later on, and Cass will obviously hit that as well as a geologist. But all these things are important. It's the understanding the environment, what it'll take to survive in space. So all those things are exciting and excite me, and that's kind of what's driven all the different projects that I've worked on. Also of note that kind of relates to what you guys are working on is before my current position, I was actually a professor in Florida for spaceflight operations, and I actually had a spacesuit lab. And so with my students, I worked on range of motion and mobility design, and tying this also to analogs, where we practice in these Mars simulations all over the planet, the different things that match up with a real mission. Like, is it remote, far away from people? Does it have the right, geology? Are you actually exploring what it would be like on the moon? And so there's lots of exciting topics that we can get into, but I think that's enough for an intro, and I'm excited to be here again. Thank you.
Thank you very much, Ryan. Yeah, I remember taking things apart as a kid also and putting them together, but I remember it not working after I put it back together more often than not. But that's another story. Now I'll turn to Cass, and let's hear a bit about your background.
Thank you. So I'm Cass. Hello, everyone. And I'm the science advisor at the Canada Aviation and Space Museum. It's in Ottawa, Ontario. And we actually have a collection of space exhibits and aviation, of course, really cool planes. But talking about space, we actually have Canadarm1 if you ever wanted to check it out. So come to the museum following Marla's comments. But I am a scientist, not an engineer. But I get to work very closely with engineers because we actually become these natural allies, especially in the space industry. And I study, not only Earth rocks, but rocks on Moon and Mars. And my specialty is actually meteorite impact craters. So, the solar system was formed by a series of collisions. And if you look up at the moon, you'll see it's riddled with craters. And that's what I'm mostly into. And I'm also a field geologist, which means I go to remote locations so that the rocks that I'm looking at are not, there's no people that live there, there's no vegetation, and they're really well preserved. And I actually worked on a crater that is the same place where Ryan completed some of his analog mission work. And so we've crossed paths a few times in the past and now in the present. But I grew up, I have a bit of a different story. I didn't start out as a space lover. I mean, I always looked up at the stars. I grew up watching Star Trek, and I always loved space, but the thought of working in the space industry in any kind of way or science was very obscure to me, because I had never met a scientist or an engineer until my first year of university. I came from a really small town in Ontario, and so I'm so happy that you guys all get to experience programs like this, because I wish I had done that when I was younger. But I'm a naturally curious, science was my better subject in school. And so I went off to university and I started actually studying in physics. And then I tried out some geology and I fell in love with rocks and then went down that path. And I worked as a geologist for a little while. And then I got the opportunity to do a master's, which was funded by the Canadian Space Agency, to study these rocks in northern Labrador that were similar to the rocks on the moon. We call these northicites, like the brighter rocks in the moon's, the lunar highlands. And so there's a big impact crater in Labrador that hit rocks really similar to the moon. And then, I jumped on the Space Agency bandwagon, and I've been on that train ever since. I started going to conferences and participating in these mission simulations, and I haven't looked back. I've just been having such wonderful experiences ever since. More on those mission simulations. So both Mark and Ryan touched on. So these are basically missions, simulated missions, whether they have astronauts or analog astronauts or rovers, robotics in some kind, where we're training, we're learning, we're testing to prepare for real missions. And I've participated in some 15 large-scale missions now, supported by the Canadian Space Agency and NASA. And most recently, I guess I'll share two fun opportunities. Most recently, just before the pandemic started, I was leading a mission called CanMoon, where we were designing operations for Artemis, for these upcoming moon missions, where the Canadian Space Agency asked, how do we run mission control and operations on the moon 24 hours a day, which is different because Mars missions don't work the same. And so we were learning how to do that. And just 2 weeks ago, I got to partake in a workshop where I got to talk to real astronauts and the real people that are designing mission control for the moon and share our ideas on how we think we should go about this and what's the best way to get the best science return. And then the last little journey I will add in is, as a field geologist working in remote locations, I actually got to partake in real astronaut training. So we got to take Canadian astronaut Jeremy Hansen on several of our field expeditions to the Arctic and train him to look at impact craters on the moon. And I hope that he actually gets to do that someday. So I think I'll stop there and look forward to talking more on this.
Well, thank you very much, Cass. And that rounds out our introductory comments. It's great to hear a little more in your own words what's gotten you to where you are today and what you're up to now. We'll shift gears now. We're going to move to some questions. I'll remind those watching in that if you have your own questions, use the slido.com site to put them forward. We're looking at them. I can't guarantee we're going to get to all of them. In fact, we're probably not able to get to all of them, but we'll pull some of them and get to them in a little bit. What I'd like to do while you're taking that opportunity is move on to some questions that we've got here. I'd like to shake up the order a bit. I'll start with Cass. Want to ask, are future engineers, people in this competition, these students, taking on a big challenge to design a city for the moon and use 2 lunar resources in that design? So they need a lot of information. Can you tell us a bit about what life is like on the moon and what resources are in fact available there?
Oh, sure, absolutely. So the moon is quite different from Earth, even though it's very close by, or close, some 400,000 kilometers away close, but it takes about 3 days to get there. And it's basically this barren, airless rock desert. The terrain, if you look up at the moon at night, you'll see that there's 2 different sorts of terrain you can actually see with the naked eye. There's the dark patches. Those are actually remnants of ancient lava flows, lava lakes on Mars. We call them mare, Maria. And the brighter parts of the moon, those are the lunar highlands, and they're made up of a different type of rock, a northocite, the one that I talked about that was in northern Labrador. And so there's, mountains, the moon is covered in impact craters, but to actually go to the moon, to think about having to operate on the moon has no atmosphere, so there's no breathable air. And in that no atmosphere, it's like a vacuum. So any astronauts that you would send, they'd have to be in pressurized suits or pressurized habitats or pressurized vehicle of some kind. I'll let the engineers handle that topic more in detail. There's no weather, so there's no clouds. It's always, during the daytime, it's always sunny. So there's no clouds to block the sun. There's no oceans of water. There's no life, no food. So on the surface, sorry. I don't want to repeat myself. So because the moon is so much smaller, it has about 1/6 Earth's gravity. So the gravity is much weaker. And so the Apollo astronauts, they actually had to learn how to bunny hop around and avoid stumbling. So it's also a challenge just to walk on the moon, let alone operate in other ways. There's also massive temperature swings on the moon. So during the lunar day, it's like boiling over 100 degrees Celsius, and during the lunar night and in shadowed areas, it's freezing, worse than freezing, colder than Antarctica. And the length of day on the moon, so the moon does a full rotation about once every 29 days. So you get 2 weeks at the equator. 1 day is about 2 Earth weeks long, and then you get 2 weeks of darkness. So 14 days of a day and 14 days of night. But if you're at the poles on the moon, there is no day and night. It's either, if you're on a topographic high, standing on the rim of a crater in the South Pole, it's always sunny, except for the sun is very low in the horizon, so it's not as strong. But if you're in a topographic low, like inside a crater, you're actually permanently in shadow. We call these permanently shadowed regions. The sun never shines there. You're always cold and it's always in darkness. The other thing I'll say about the moon is it's covered in what we call regolith. And this is a product of these billions of years of impacts and collisions from asteroids and comets. And so it's basically just keeps mashing up the surface of the moon, and it keeps mixing it up. And now there's meters thick of this regolith, this soil, this sandy fragments of rock around the moon. And part of that, the finer particles, are what Ryan mentioned, is lunar dust. So they're dust, it's really, really tiny particles or grains, but they're very glassy and they're very sharp, and they get into spacesuits and they cause trouble for the engineers trying to work on the moon. And then the last thing is there's no magnetic field on the moon. And on Earth, the magnetic field protects us from dangerous solar radiation and cosmic rays. So that's another thing you might want to think about. When it comes to resources, the moon has a variety of resources, but the tricky thing is that they're not widespread. So depending on what you want to do, you have to decide, like, location matters where you land. The one thing that is everywhere is regolith, so that sandy material. And you could use regolith as a building material. NASA's working now on how to make basically a lunar concrete out of this material, for example. You could also, the other things on the moon, you could actually take that regolith and you can extract some of the elements in it. So it's rich in silicon, oxygen, iron, calcium, aluminum, titanium. I could keep listing these off, but there's different challenges involved in extracting those different types of things from the regolith. But the regolith is everywhere. The second resource I would talk about is the sun. So like I mentioned, if you're at the equator, you get 2 weeks of sun, but then 2 weeks of no sun. So you'd have to figure out how to do that. And if you're at the poles, again, you get full sun if you're on a topographic high, but no sun in the lows, but it's weaker. And then the last resource I'll point out is water. So in those cold traps in the craters, but only at the poles, we actually have discovered that there is water trapped in there. Not a lot of water, more like 5–10%, and it's mixed in with the regolith and the dust, so it'll still be tricky to get out to extract it, but there definitely is water in the moon. And water we could use not just for drinking, but you could break it into oxygen and hydrogen, and both of which can be used for rocket fuel. So I'll stop there.
Thanks a lot, Gus. Fascinating to hear. Nice to know there are some resources up there. I'll turn next to Marla. Given all that we've learned from Cass now, it's a tough place to operate, the moon. Creating a city on the moon, people are going to have to communicate. You can't just open the door and call out to your neighbor, I suppose. What tips do you have for students in terms of designing ways in their cities to communicate with each other?
Yeah, that's a great question. Very important. I think on any planet, we can probably look at how do we communicate here on Earth and draw from that. So we have the internet, we have cell phones, some people still have landlines. Actually, where I live, I am just 40 minutes just north of Toronto, from the CN Tower, but there's some areas here in Caledon where they can't actually get high-speed internet. The best way to do that is by satellite, by Starlink that just went up. So that could also be an issue on the moon. And the reason for that is there's no infrastructure, there's no cables to get that high-speed internet here. So maybe you might need cables on the moon. Maybe you might need cell phone towers to communicate. Something to consider is, what are you talking to, or who are you talking to? Are you talking to other people in spacesuits? Are you talking to a rover? Are you talking to a building? Or do you need to talk back to Earth? If you have to talk back to Earth, do you need something in space to pass that message on? Do you need something on Earth to receive that message? So in the space world, we often talk about how you have a ground element to receive those communication signals from space, as well as this space element, which might be a satellite with a communications antenna to relay that from our spacecraft. So you might want to think of things like that. The other thing with space communication is the farther away you are, you get a bit of a delay in your signal. Luckily on the moon, to go from one way, the moon to the Earth, that signal only takes about 1 second, 1.25 seconds. But if you want to talk from the moon to the Earth and back to the moon, that's going to be 2 seconds, which you as a person would know. So if you actually watch some of the old videos of the first moon landing, you'll notice that there's a bit of a delay between when ground control communicates and when the astronauts respond, and that's because of this delay. That delay is actually caused by when you send a communication signal, it can only go fast as light can. I would also think about what is it and how are you trying to communicate? Are you trying to send voice, or are you trying to send a picture or a video? If you're trying to send a picture or a video, that's going to take more data, and that might need more energy or more power to send that message and different infrastructure to do that. So for you guys out there, think about ways that you communicate in your day-to-day life and think about what goes wrong. So if you've ever been on an online virtual school class and your sister might be trying to watch Netflix at the same time as you trying to be on Zoom, and then it just all cuts out, well, that's because something in your communication infrastructure isn't working. So if you kind of relate back to that and think about what caused that, is it because we're trying to send too much video at the same time? That would be a great way to troubleshoot how your lunar communication system is going to work. So good luck with that. Have fun.
Thanks a lot, Marla. Yeah, 2-second delay. I need a lot more than that after someone asks me a question, because I got to put my thoughts together. So I wouldn't mind the 2-second delay. Let me turn to Ryan now. A question for you. Many things make living on the moon challenging for people. There's no air, it's really cold at night, it's really hot in the day. What tips might you have for students on how they can protect people, future citizens of this city, from hazards on the moon?
Yeah, excellent question. First, let me swap here so we can journey to the moon together here with my background. All right, so there we are, the real thing right behind me. Well, a photo of it. it's always exciting to look at these historical photos because we get a good feel for what it was like working there and living there. Only, a handful of people, 12, have ever walked on the surface of the moon. And so I want to go back to the human side of this question of like, what does it take to actually survive? Because those are the fundamental things you need to think about in order to then build your city around it. It's something that a lot of people call human-centric design, trying to figure out what did the humans actually need to survive, and then building up, if you will, the next level. And so the reason we do this and we go through this kind of part of the design process is that we really want to think about what are all the things that could go wrong, what are the hazards, because those are the things that we want to improve upon the design to make sure we keep people safe. And so that's the kind of the bottom line of safety, if you will. And so Cass gave a great overview of the moon. I'm not going to add anything to that. There's nothing to add, but the two main things that kind of come up for human health are the radiation from mostly from the sun and from galactic cosmic rays. So that intense activity, if there's like a solar particle event, all those charged electrons can affect the human body. And so a lot of you might be aware of radiation concerns here on Earth and how radiation is also used for treatments. So it's definitely something we have to protect against. The other is the lunar dust. I've studied lunar dust abrasion, which is how it basically is like a rough, diamond cutting sandpaper. This is broken glass all over the moon. So it's not like a walk on the beach. When you go to the beach, the waves have smoothed all those sand particles into nice little balls. Well, on the moon, you're walking on glass. So again, if you look behind me, you can see the astronauts, their spacesuits they're not white. They're kind of grayish because all that lunar dust is actually embedded into the materials. It's scratched up and gotten into the materials itself. It can be very dangerous. So what I'd like to do is just kind of talk about the top level tiers now of life support. There's really 3 fundamental tiers. So number one, what's the number one thing you need to do with humans in an extreme environment? Well, it's keep them alive. So no matter what, you have to have a system that keeps them alive. Even if it's a spacesuit that's a bubble. I joke about it a lot with my former students, like, yeah, you could just have a bubble spacesuit and provide them oxygen and they're good to go, right? So the second thing is, well, you can't get things done in a bubble. So the second one is you need to be able to function, actually do your job. If it's a mission, just like a NASA mission, like the starting point, they need to be able to take samples, get data, be able to function, right? But as you guys are developing a city, we have to start thinking about long duration spaceflight. And it's not just about surviving anymore. It's not just about, being able to function and get these resources. You have to have a level of comfort as well. So there's a lot of different aspects. There's the psychology or mental well-being. There's the physiological side of it, of your body, like just think of exercise and activity and keeping your body healthy. So all these things and the social aspect of interacting with other people, if they're there with you or if they're back on Earth. And as you've just heard, there's a time delay. So level 3 is really comfort. And then I just want to do a really, really basic kind of human 101. Like, what do we need? Like, what does the human body actually need? So we know we need to have a habitable environment, which means the right temperature, the right pressure. But what our body needs to actually consume is energy. And that's either through, food or other means, liquid food sometimes. A lot of us are working at home and sometimes we actually have less time for lunch, which should be the other way around, but that's okay. We need oxygen. Our bodies need oxygen to survive, and we need water. So again, going back to resources on the moon, water is one of those target areas that we want to do more research and discovery about. And that's really why the Artemis missions are targeting the South Pole, is to look for those permanently shattered regions, areas where water might be more abundant, so that we can understand how to extract it and process it. And then just on the other side, so those are the things our body needs. We're producing lots of stuff all the time. So right now I'm producing noise, but we produce heat. We produce carbon dioxide, so we have to get rid of that. That if that builds up, that can be dangerous for the crew. We have waste, so I'll be adult here and say urine and feces, but we have waste that we have to deal with. Waste management is really important. There's been a lot of people who have designed habitats and space stations. And then the first question that the Eclipse engineer will ask them is, where's the bathroom? So that's extremely important to keep in mind. And then we also perspire and respire water as well. So it goes back into the atmosphere and it makes it humid. So we have to deal with that as well, because we can't let the equipment inside of our habitats, spacesuits and everything else get too humid. It might damage the electronics or other equipment. So that was kind of the quick overview. I do want to get to other questions. So those are the things that you should keep in mind about the humans specifically and all those hazards that are out there, especially on the moon.
Thanks very much, Ryan. Yeah, succinctly put, keep them alive. Good start. What I'd like to do now is check and see what's been happening on Slido, and the good news and bad news is there. We got 150 questions and not that much time left. So let me turn to Kim now from Engineers Canada, who's been monitoring that. Kim, do you have any questions that we should move to now that you think are appropriate?
Yeah, actually, we have a very bright group that picked up this new tech real fast. So they've been actually voting for the questions that they want to have asked first and second. So that's the order I'm going to go with, the most popular votes. So the first question is, where would we plant trees and homes so we get oxygen?
Would we plant trees?
Oh, would we
and
plant
homes?
trees? Sorry, yeah, would we plant trees and homes so we can get some oxygen?
Anyone want to tackle that first?
I can give a short part of that answer.
Okay.
So planting of trees would have to happen within some sort of greenhouse structure. Just like humans, trees need a pressure environment. They won't survive in the vacuum of the moon. They might need nutrients, or they will need nutrients in their soil. So it would have to be a mixture, possibly mixed with the lunar regolith. There's been studies to look at that, as well as Martian soils mixed into it. If any of you have watched The Martian, they kind of alluded to using waste matter and other products and Martian soil to mix it up to be able to grow potatoes. Trees would be awesome because you would have that connection back to Earth. As you can see from the image behind me, everything is very monochromatic. You need some color. It has psychological benefits to make you feel like you're back home and everything else. So we might not be growing full-size trees at first, but it would be really cool to have them there, of course. So I think that is a great goal, to have that inside part of your habitats.
Thanks a lot. Why don't we move to another question, Kim, since that was a thorough answer?
Sure. So the next question is, how much weight can a rocket carry?
Anybody know how much weight a rocket carries? Marla, Cass?
I'm going to say it depends on the rocket, and it depends on what you're trying to get up there. So actually, this is kind of related to the project I'm working on. It's really not about weight, because once you're in space, gravity, so weight doesn't really matter. A lot of the fuel is actually used to get off Earth. It's more about the size of what you're trying to launch. So if you're following space, Perseverance, that was the Mars rover that landed a few weeks ago. That's the size of an SUV. And right now, our biggest limitation to get things in orbit is the size of what you can put in a rocket. So my project right now at MDA is trying to kind of combat that and looking at how can we build things in orbit. So one of the payloads that our spacecraft has is actually kind of a 3D printer that can print a 10-meter long beam in orbit. And then our robot Spider is able to pick it up and move it around. And Spider's also able to build really, really, really big antennas that we can't launch on Earth. And the way we do that is we send little panels that are kind of flat packed, like reminds me of IKEA furniture, and then you can build it robotically in space. So that's never been done before, and that's why it's a tech demonstrator mission. So it's not necessarily about weight. That is a factor. The heavier it is, the more expensive it's going to be, but it's more a size limitation. Yeah.
Okay. Well, thank you very much. Yeah, I guess weight doesn't matter when you're up there, but boy, it sure matters in getting it up there. Fascinating questions coming in. Kim, what else have we got?
So the next question is, if we lived on the moon, would we get hit by asteroids more often?
I can take that.
Okay, Cass, as I duck.
Look out. So the short answer is yes. So Earth gets hit by micrometeorites or meteorites every single day, but what we have that the moon doesn't is an atmosphere. And the atmosphere around Earth actually protects us from all the smaller rocks that are flying around in space, and that might impact the Earth. And so they actually break up most of the smaller, basketball and smaller sized asteroids out there. They break up before they hit the ground, and there really is no danger. But on the moon, there is no atmosphere to protect from those. And so micrometeorites and the larger ones, of course, are a danger on the moon. And so there are small, the moon is getting bombarded every day much more than Earth is because of that lack of protective air cover.
Okay, one more challenge to look out for in designing a lunar city. Great. Kim, what's next?
Well, we have a number of questions that are related to water, and each of them have a slightly different angle. So maybe I'll just read a couple of them so you can get a sense of what the students are trying to get their heads around. So one says, do we burn the ice water on the moon with flamethrowers? Look, so how are we actually getting the water? And could we make artificial ponds and lakes? Could we make a water plant? So basically there's a real focus around here. It's like, how do we actually, they all understand that water is really important and there doesn't seem to be much of it on the moon. So what do you recommend to them when they're thinking about how do we make sure we have water?
Who wants to deal with water on the moon?
I think we all do.
Okay, yeah, that's my fear.
Yeah. We should definitely we all want to be part of that. Yeah, it's hard to extract. So when you think about these resources, try to think of it as you're not going in and just scooping up a bucket of water from the lake. Think of it like the mining industry. Like you need to go in there, you need to grab all these rocks, crush them and sort them, and maybe cook them to get gases out of them. And that's how you're going to get these products out of them. So you need to have some sort of processing plant in order to actually get the water. And then I'd be more than happy to go for a lunar swim. So definitely set that up.
Thank you. Anyone else thoughts on the water problem for the moon?
I'll just add, I completely agree with that. It's like a mining process, and the water is not, easily accessible because it's mixed in with all the rocks. So you have to break it all out. But the other thing is, if you wanted to make a pool on the moon, again, if you had liquid water on the moon, it wouldn't stay there very long. So you'd still have to have it in some kind of a pressurized habitat, pressurized pool arena.
Yes, a challenge. Okay. Water is an issue on people's minds. That makes sense. Kim, next questions?
So there's another question about the materials. And so I wonder if, like, Marla, I know you caught my attention. We're talking about 3D printers. So you'll need lots of materials to live there and a lot of rockets to carry it. How long would it take? Would you have to be doing like constant trips? How do they manage trying to get those resources? Because they'll use what they can on the moon, but to build a city, they'll probably have to try and bring some stuff with them, right? So what kind of tips do you have there?
I know one thing that's been kind of talked about is doing it kind of multi-stage. So before you actually send people, you can maybe send everything you need. And there's a lot we can do autonomously without people using robotics. So you could send a whole bunch of supplies up there first in one mission. And maybe it might be something that you can use to make more things once you get people there, or maybe it's something that could autonomously, using a robot, build things so that when people are there, everything's already there. It will take multiple trips, but it all depends on kind of what your approach is and how you're going to do it. So maybe some of you out there want people to build everything, which is super cool because people need jobs on the moon too. But maybe others want to do something where you're going to maybe have the robot set everything up first and then people can just move in. So yeah, I don't know, Ryan, I feel like you'd have good comments on this too.
No, I agree with that. I I put up one more image. This is a rendering of what I'm working on. This is the human landing system. And in that middle is the Coke can, if you will, is the crew module. And that's where the humans are, the life support. And so as part of this, I guess you could say, infrastructure of what this team is building, is that you can put other things under that. You can put a rover, you could put some sort of what's called ISRU we've been talking about, but we haven't said is in situ resource utilization. That means living off the land, using the resources and creating something that you can then use to live. So you could actually land tons of different things, and lots of companies are doing things like this. And so those are other things that you can consider. So I would encourage you to definitely dream big. Think about, what do you want it to look like? Like, we want the Olympic Stadium, we want the biggest, and all the things we want to have on Earth. And then try to think about, okay, if you're about to just walk out the door out of your house and in your backyard, and you only had a backpack full of stuff, what would you start with in order to get to that big dream? So definitely think about those steps. And I think if you can start filling in the gaps of those steps, then you really start to make those like dreams into reality.
Thank you very much. Fascinating hearing the questions. So let's keep on with that for as long as we can. Kim, what else have we got lined up?
Well, we're starting to get some really interesting questions that are starting to dive into sort of the economic parts of being on the moon, and then the whole social parts of being on the moon. So we know that, even here we hear people talking about the importance of the economy all the time, and then you also hear about things about war. So it's like, if you're building these cities, so one specific question is, do you think that there will be wars over territory on the moon? So I guess if you're building a future city, maybe how do we build a city that maybe avoids, some of those kinds of conflicts? And then there's some other questions around, like, can we mine for iron as a good, maybe first kind of business or something on the moon? So maybe if you guys just have any tips around it, this is an opportunity. It's a challenge to build a moon, but it's also an opportunity to rebuild a society. What are some of the things that you think might be interesting for them to consider as they're designing their cities that keeps those elements at the forefront?
Wow, that's a loaded question, whether it's mining or other things. Let me turn. Cass, any thoughts on that?
I'll take a stab at part of it.
Okay.
So to begin, space exploration for many, many decades now has been a peaceful international, a center for international cooperation. It's one of those places where we try not to bring the conflicts between nations into it. It might have started out that way, but there's definitely been a peaceful enterprise ever since. And so I'll first start with that, but then I'll say, on the moon, there actually there's very few laws guiding who actually has access to these minerals and resources on the moon. And so right now, the only law that really exists is that no one can own the moon. No one nation, America, Russia, they're not allowed to say the moon is mine. I mean, Apollo planted the flag, but it's just a symbol to say, hey, we accomplished this amazing achievement. So no one owns the moon. And actually, so there's lawyers and nations getting together right now, trying to come to some agreements over, okay, we can't own the moon, but can we drill for resources and then make a profit from those? And those laws don't exist yet. We don't know, and everyone has a different opinion because everyone has a different agenda. And so there definitely is some friction that could come about from that. I think it's going to be a finders keepers who gets theirs first kind of thing, but that's stuff that's still a little bit up in the air. But I'm hoping with all of the existing plans to go to the moon right now are already international collaborations. Everyone's already collaborating. This mission to the moon, it's NASA, it's Canadian Space Agency, it's European Space Agency. China and Russia have made an agreement. They want to make their own, outpost on the moon. And so everyone is currently still working together and wanting and open to collaboration. So it's definitely starting off peaceful.
Good to hear. Good to hear indeed. Anyone else want to venture? That was loaded, that question, with lots of elements. Was there anything, Marla, anything you wanted to add there?
Well, I'm just thinking of like my time in the Air Force, and A lot of what we did as an Air Force was looking at more how do we help people, so search and rescue, how do we and we actually work a lot with other countries anyways, so even in like a war scenario, if you want to call it that, there's a lot of international collaboration, just like there is in space. Even with my projects I've been working on at MDA, there's a lot of collaboration with our American friends as well. So I think space is different. And as was mentioned, it says time to rebuild humanity. I think you guys could think of like, how has our society changed because of COVID? Now that we're all isolated, you're going to be isolated on the moon. So maybe some of the changes that you've seen in your communities, that might be the type of things we'll see if we go to the moon, where people are kind of isolated from the rest of the earth. Yeah, very, very interesting, very hard question, I would say, though.
Nice to have the tables turned on us and hard questions thrown our way. That's wonderful. I want to throw in a question at this time. This is a kind of engineering activity, build a city on the moon. Engineers don't do things on their own anymore. It's a team activity. They have to work together, do design in teams, manage their projects, carry out research where they don't know answers. Do you have any tips? And I can turn this to all of you on how these student teams in this competition might manage trying to do this on a small but student scale. Let me turn in order. Ryan first.
Yeah, I mean, with any team, one of the most critical parts is communication. So if you guys can establish early a way that everyone can have their voices heard, to make sure that all ideas are captured, take notes, write down like, okay, we've got these ideas, and then you can start grouping them together. Like, oh, we've got these 5 or 6 ideas about what the housing might look like. So, make sure you get everyone's input. If somebody's maybe not contributing, maybe you can try to find an area that connects with them, and maybe find a way that they might actually have lots of ideas that are going to benefit the team. So I would say communication is probably one of the most important things to working together.
Great, thank you very much. Cass, anything to add on that?
I completely agree. Communication. I would say, start with understanding the problem and the specific problem that you want to focus on. This is a thing that engineers and scientists always have to do, no matter what project they're starting on. Is the more you understand the project problem, the more you put your research in, the better you will be equipped to approach a solution, a working solution to it. So I would say understand your problem.
Wonderful. Marla, what about you? Any thoughts on that general area?
Yeah, so just to kind of relate what Cass and Ryan said to what I've actually seen working in the space industry is it always starts off with, you have a list of requirements, a list of what is it that your city needs, what is it that you need to do. And then from there, within your team, you have some people that might go and design the components that we need to do those requirements. We might have people that might go and look at that design and do analysis on it and say, and think critically, is this going to work? Then we might have different people who go and build prototypes, maybe practice building part of the model and practice testing it out to see if it's going to work. And then you might find that maybe your design through the analysis isn't going to work. So you have to go back to the start and redesign it. And then the other thing that's important is it's different. Everybody has different strengths and weaknesses. So we have people that are really good at planning, and all they do is they just plan and make sure everybody else is on track. We have technicians who just do the build. They're not involved in the design. They're just given a drawing and they build it, and they do a really great job at it. Yeah, so just look at your team, your group's strengths and weaknesses. Don't be afraid to make mistakes. And if you have to start back from the drawing board, that's actually what happens in real life. So have a lot of fun with it.
Okay, that's wonderful. Look, I really appreciate all those thoughts, and I think our audience does too. The Slido has worked wonderfully, and that's a good news, bad news story. We're up to 200 questions, so we clearly have not been able to get to all the questions. I apologize for that. We had no idea how much we would get by way of questions, and I think we're simply overwhelmed with that. So we can't deal with them all, but it's good. It shows the interest. You can search out answers on your own, whether it's using resources on the internet, resources through books and things like that, or turning to other experts. Many more experts than the 3 we have here exist and are available to you. So I think instead of getting back to the questions, we're going to have to start winding this up. I want to thank all of you for attending, first of all. And thank you for participating in this Future Cities competition. I think it's a wonderful way to enhance your education and provoke that curiosity that people have, especially in things like the moon. I also want to thank the organizers of this, Engineers Canada, and Kim especially for helping out in organizing this event. I want to thank the Future City organization for putting together the competition. I want to thank my university, Ontario Tech University, for helping to organize as well, especially the Faculty of Engineering and Applied Science, which has played a role with Future Cities for some years now. And at that point, I'm going to wish everyone good luck in their projects. We really look forward to hearing what comes out of this in May, what you present when it comes to the final showcase. At this point in time, I'm going to turn it back for a moment to Kim. Is there anything else, Kim, that you wanted to add from Engineers Canada perspective?
I just wanted to confirm with everyone who's on the call today that this has been recorded, and so we will make sure that everyone gets a copy of this. So because I know there's a lot of great content that they shared, and so don't worry, you'll have an opportunity to listen to it again. I also noticed that you had a couple of questions in there that was very specific to designing the city, and so I'll make note of those, and I'll follow up with everyone with the answers to those questions. So thank you again. Along with Mark, I just want to thank all the panelists. What a brilliant panel! Like, how lucky is it that we have such talented people who are working in space here in Canada? I think that's one of the things that I really learned from this is I didn't realize how much the space industry is booming and how much as Canadians we are actively engaged in it. So thank you so much for your time today.
All right, well, thank you very much then, everyone. I guess this is a point where